we're moving on to talk about relative extrema. And all relative extrema are the hills and the valleys of the graph. We have relative extrema include relative maximums as well as relative minimums. So looking at this graph here to give us definitions for relative maximums and minimums. Notice that here, surrounding this x value of a, this point right there is higher than all of the points that are immediately around it. So that orange point is higher than the pieces of the graph to the left and the right that I shaded in blue. That is the definition of a relative maximum, is that the y value at a is greater than all the other y values that are near a. On the other hand, a relative minimum, we have that going on at B. Notice that green point there in B. If I shade the points that are directly to the left of it and directly to the right of it, that green point is lower than all of those points. That is the definition of a relative minimum. Another way to think about relative maximums and minimums is notice that this function was increasing on the interval from negative infinity up until it got to that x value of a, and then it started decreasing once it got past a. It decreases all the way from a to b, so I'll just stop this decreasing interval at b. But what's important there is that when a graph switches from increasing to decreasing, you have a relative maximum. On the other hand, when a graph switches from decreasing on this blue part to the left of B to increasing on the green part to the right of B, because that graph is increasing from B off to infinity, this x value of B, and the graph does not stop going up. When the graph switches from decreasing to increasing, there you have a relative minimum. That is just the hills and the valleys of the graph. So let's look at this example here. We have this function here. We want to find the relative extrema. The first blank we want to fill in reads the point blank is the lowest point in the small interval surrounding which x value. So we're looking for places where the graph has switched from decreasing to increasing. We're looking for the lowest points. Well, this point here at -2, -1, that is the lowest point at all of these pieces of the graph that are surrounding it. Those two pieces that I shaded to the left and the right in orange are higher up on the graph than the point -2, -1, so that is a relative minimum happening there. So the point -2, -1 is the lowest point in the small interval surrounding the x value of -2. Now the next line is very important because it tells us how we write our answer. If I ask what is the relative minimum, the relative minimum is -1. It is located at -2. So generally speaking, the location of the relative extrema is the x value. The location of the relative extrema is the x value. That tells you where they are located at. The value of the relative extrema is the y value. That tells you what the relative extrema is. Now let's go on to find what the relative. So this first set right here, all of this here was for the relative minimum. And I know that because it says lowest point there. And now we're going to go on to look for the relative maximum because here they're asking us for the highest point. So we're looking for the hills in the graph. We have a hill right here happening at the point 0, 1. That is the highest point in the small interval surrounding x is equal to 0. So notice that the pieces of the graph that I shaded in blue on both sides of that point are lower than that point. So that tells us that at x equal to 0, we have a relative maximum of 1. Looking at example 4, we're again going on to find hills and valleys of this graph. This graph has two relative minimums and one relative maximum. One of the relative minimums is here, which I can see is happening at the x value of -1, and it goes down to -2. That's the point -1, -2. So at x equal -1, the function has a relative minimum of -2. Now let's move on and talk about the second relative minimum that the graph has, which is happening here. The next valley in the graph, that is at the point 4, 0. So at x equal to 4, the function has a relative minimum of 0. And then finally, the relative maximum of the graph is happening there. We're looking for now the hills that are in the graph where the graph changes from increasing to decreasing. This is at the point 2, 3. So at x equal to 2, the function has a relative maximum of 3. In our last example, we want to find the same thing, any relative extrema. Remember that relative extrema happen where the graph changes from increasing to decreasing or from decreasing to increasing. When we look at this graph, we don't particularly see any hills or any valleys of the graph. I will ask that you go ahead and add arrows onto this graph because that graph does not stop going. I hope this graph looks familiar. It should look like a graph that we talked about when we learned about parent functions. This is the cube function. So that's kind of like all that lesson on parent functions was about, that you should be able to look at this graph and say, oh, hey, I know what that equation is. This is the equation of y is equal to x cubed. But I digress. So let's talk about whether or not this function changes from increasing to decreasing or vice versa, because it's only when we have a change that we would have a relative extrema. So as we begin to trace through the graph from the left to the right, tracing through, my pen is moving upward. My pen is still moving upward on that part in the middle. Sometimes people would try to argue that the graph is horizontal right there. It is not. It is gradually continuing to go up as it goes through that swiggle. The graph is still going up here, still going up here. So this function is, for one, always increasing. This function is increasing on its entire domain. So if I was asked where it was increasing, my answer would have been negative infinity to positive infinity. And if the graph is always increasing, then it cannot have any relative extrema, because the only way you get relative extrema is by switching from increasing to decreasing or switching from decreasing to increasing. So if it's always increasing, no relative extrema. If it's always decreasing, no relative extrema.